All right, so we're going to take a look at chemical kinetics today. And this is the information that you're going to need in order to get started with this unit. My hope is that you'll take the time along with your reading to take notes on this so that once we come into class, we can spend our time focused on going through examples. Well, let's go ahead and get into it. Now, our learning goal for today is going to be to define kinetics and rate. Now, not only define them in terms of their actual literal definition, but also how we will be utilizing this information throughout this unit. Now, kinetics concerns itself mainly with the rate of reaction. How does the reaction happen? How fast does it happen? What pathway or what changes occur during this process? The general idea that we're going to utilize is this, that the rate of reaction is measured by the decrease in concentration of a reactant or in the increase of the concentration of the product. Therefore, giving us a formula of the change in concentration, rate equals the change in concentration of a species divided by the change in time over which the reaction occurs. This is going to be our basic information, and we can still utilize this information in this formula later on into this unit. Now, what do we do with the coefficients? Usually when we look at a chemical reaction, most times there is some coefficient there. How do we utilize this information, and does it play a part? Now, using our general equation given to us here, we're going to look at the comparison of the rates of the reactants and the products. What do I mean? Given this basic equation of A plus 2B yields C plus D, we'll look at this coefficient 2 sitting out front, and that lets us know that reactant B disappears twice as fast as products C and D are formed. Now, if we're looking at this and we want to determine or to make sure that people understand and know that this is the disappearance of one, what we'll do is we'll actually put the algebraic sign of a negative symbol out in front. This makes sure that we end up with a positive value for our rate. So, in terms of our overall picture, if we are writing the rate in terms of the disappearance of A, we would write rate equals the negative change in concentration of A divided by the change in time. If we wanted to change this and now write our rate in terms of the appearance of our products, we could say rate equals the change in concentration of C or D divided by, again, the time that it takes for the reaction to actually occur. Using our general, we now can understand how the rate works for the entire reaction. And if you notice, take a moment and look here at our rate for B. We say in terms of looking at the overall reaction, we have half of the negative value of the change in concentration of reactant B over the time to equal out to where our other reactant as well as our products are found. Just things to keep in mind as we continue on looking at those relationships, since it disappears twice as fast. Now, the rate of reaction at any instant in time can be determined by plotting the concentration against time. What do we mean? If I'd like to find out what is the rate of reaction at a certain given time, so if here's my chart, and this is my concentration of C at a given time, and we'll use seconds as our unit, my graph should look something like this. Now, if I would like to find out what the rate is at this point, we'll say this is 20 seconds. The way for me to find that out is I need to find what is the slope, the negative of the slope of the tangent line at that time. So, if I continue and extend my line here, I need to draw a tangent line that's going to connect at that point. By finding the slope of this line, I'll be able to find out what the rate is at that given time. This will be a little bit more useful as we continue on. But just prepare your mind that a little bit of Algebra 2 and Algebra 1 will be making its way back into this section. Now, our final little part for this first section is we're going to look at the units. And this is just something to keep in mind, and it will change slightly in terms of what we're going to be doing. But the unit for rate that we're going to utilize throughout this whole unit is moles per liter times some unit of time. Now, this brings us to the end of our section 1. Make sure that you go back over it. If there's things that are still unclear, write down your questions so that once we come into class, we'll be able to answer them correctly and you'll be able to get the best understanding. Have a great evening. I'll see you tomorrow.